the mole, okay? So we're basically going back about a week from where we left off. I didn't really want to pick up on something new when it's been 2 weeks since we've done anything, okay? So we're going to go ahead and go over the mole. My pre-P class, I know you guys had a quiz on this. Planning on starting to grade those today, okay? So for you guys, my pre-P class, this might be a bit monotonous, but just bear with it, please. Because I'm sure most of y'all have forgotten this stuff as well, okay? So we're going to go ahead and go over this. So what you'll need is your notes, okay? Your calculators, if you have one, and a periodic table, okay? So please go ahead and get that out now. Pause the video if you don't already have it out. Now, so I said this was going to be a review. I'm going to make this as quick and painless as possible. I know you guys have other classes to take care of. I know some of you might be borrowing or might be sharing one computer at home. I don't want to take up too much of your time, so I'm going to try to make this as straightforward as possible, okay? Hoping not to take any longer than 10 minutes from the moment we get started on this lesson, all right? Okay, so we are going to be talking about the mole, okay, but not the animal, all right? We are talking about the number 6.022 times 10 to the 23rd. Now, the individual who came up with this number, as you all know, goes by the name of Lorenzo Romano Amadeo Carlo Avogadro, right? It's a mouthful. So we don't go by this long name of his. We just refer to him as Avogadro, okay? By his actual name of Avogadro, okay? Not avocado, all right? We're not working with this, okay? I know that as a little trick, some of y'all would call him avocado. If you're going to do that, that's fine. I'm not going to do that because I want to give the guy a little bit of justice. So I'm going to be referring to him. Now recall that the analogy we used for the mole is 1 dozen, right? And we said that 1 dozen of anything, it doesn't matter what we're working with, always gives us 12 units. So if we had 1 dozen students, you know that the number would remain 12. We'd have 12 students. If we had 12 teachers, we'd have, a dozen teachers, we'd have a dozen teachers. If we had a dozen elephants, we'd have 12 elephants, right? Now, this concept right here is a great analogy for the mole, okay? Now, when we're talking about the mole, it's the same thing. We're just working with a different number. So whenever we talk about 1 mole, we're talking about having a much larger number of units, specifically 6.022 times 10 to the 23rd. I'll put units there, okay? So if we had a mole of, let's say, oxygen atoms, we would have 6.022 times 10 to the 23rd oxygen atoms. If we had a mole of students, we would have 6.022 times 10 to the 23rd students. If we had a mole of schools, we would have 6.022 times 10 to the 23rd schools. If we had a mole of the new Weekend album, we'd have 6.022 times 10 to the 23rd albums by the Weekend, right? So there's our quick little review of the mole. Okay, now the next thing I want to review briefly with you guys is molar mass. So for example, let's go ahead and take a look at this problem right here. It says determine the molar mass of CO2, okay? Now, remember, to find the molar mass, we need to reference with carbon and oxygen, okay? We have 1 carbon and we have 2 oxygens, okay? So we're going to go ahead and look at the molar mass, or the atomic mass of carbon, and then we're going to look at the atomic mass of oxygen, okay? So let's go ahead and start off with carbon, Okay, the molar mass, atomic mass units, we're just going to go ahead and write 12.011 grams. Okay, now we're going to do the same thing for oxygen. Okay, so let's go ahead and write that in there. So we have 15.999 for oxygen. Now, we have 2 atoms of oxygen, right? So we're going to have to multiply that by 2. Okay, and we'll just say that that's about 32 grams. Right, so what's the next step? Well, now we have to add our 12.011 grams plus our 32 grams from oxygen, right? And that goes ahead and adds up to about 44 grams per mole. So that right there is our molar mass of carbon dioxide. So just remember that the molar mass is basically the sum of atomic masses of the atoms making up the compound. Okay, in this case, we just had 1 carbon, 2 oxygens, so we needed to add up 1 carbon, the mass of 1 carbon, and the mass of 2 oxygens, giving us this guy right here. Okay, so now that we had, 50 grams of CO2. If we had 50 grams, moving on, okay, we're going to make that scheme again. Now, you guys, most of you should already have this in your notes. Again, I'm just going to cover it just as a quick little review. So what we're working with here is we have grams, moles, and molecules. Okay, so we want to know first, how do we get from grams over to moles? And then once we're at moles, how do we get over here to molecules? Okay, so the first thing we're going to do is go from grams to moles. Okay, how do we get from grams to moles? Okay, the first thing we do is we look at the molar mass, and we're going to go ahead and take the grams that we're given and divide it by the molar mass. Okay, so for instance, if we had, let's go ahead, of CO2, we'd want to divide that by the molar mass to get to moles. And we'll have an example problem of that soon enough. So moving on. So now we're at moles. How do we go from moles to molecules? Okay, well, we have to go ahead and use, let me get the right color there. We have to go ahead and use Avogadro's number, okay? Now, we're going to use Avogadro's number instead of multiplying like we did initially to go from grams to moles. We're going to actually, instead of dividing by the molar mass to go from grams to moles, now we're going to be multiplying, and we're going to be multiplying by Avogadro's number. Okay, so now we're going to go ahead and work our way back. Remember, it's just the reverse of what we did. So instead of multiplying by Avogadro's number, if we want to go from molecules to moles, we are now going to divide. Divide by Avogadro's number. Okay, and then the same thing goes for going from moles back to grams. Instead of dividing by molar mass, we are going to multiply by molar mass. Okay, multiply by molar mass. Okay, so we're going to go ahead and reference this little scheme for the remaining problems we have left, okay? Because from this point on, we just have a couple of practice problems. About 4 practice problems, okay? We're going to have 2 practice problems, okay? One for going from grams to moles, and then another from going back from moles to grams. And then the following 2 are from moles to molecules, molecules to moles. okay? And we are going to be referencing this thing right here, okay? If you don't have this in your notes already, or if, again, you lost your notes, whatever, go ahead and please copy this down now. So pause the video, jot this down in your notes, and then we'll go ahead and move on, okay? We're looking for moles, and we want to convert it into... we're looking for grams, and we want to convert it into moles, right? So here's grams. Follow this arrow to get to moles. We need to divide by the molar mass. And look, guys, I know that some of y'all are probably rolling your eyes at how slow this is going. If you know what to do, go ahead and do it. Just get ahead. I'd like to review this, again, because it's been 2 weeks. So we're going to go ahead and follow through with this then. We're going to take our 25 grams of water and then divide it by the molar mass of water to get moles of water, okay? So let's go ahead and take a look at our scheme. Okay, we have moles and we want to get to grams. So to get over here to grams, we're going to have to go ahead and multiply the number of moles we're given by the molar mass of that compound. Okay, so let's go ahead and do here. And we know that we're going to be going from moles to grams. We have to multiply by the molar mass. Okay, so let's go ahead. So to get from moles to molecules, moles over here to molecules, we need to multiply by Avogadro's number. Go from molecules to moles, we need to divide now by Avogadro's number. Okay, so let's go ahead and... All right, let's look at this problem. It says to convert 25 grams of water into moles of water, okay? So in this problem, what's the first thing that we need to do? We need to go ahead and find the molar mass of water, okay? So for that, remember, we have to refer to our periodic table, right? So we are working with 1 hydrogen and 2 oxygens, okay? So let's go ahead and take a look at that periodic table, okay? So we need 79 grams, okay? So let's go ahead and write that in. 1.0079 grams. Now we have 2 hydrogens in H2O. Okay, so we have to take that into account. So what are we going to do? We're going to go ahead and multiply that mass by 2, and we're just going to go ahead and round it off to 2 grams. Now, again, we're going to do the same thing for our oxygen. Okay, let's go ahead and take a look at the periodic table one more time and write that number in. So we have 15.999 grams. Okay, what do we do now? Same thing we did in that initial example, right? We go ahead and take our 2 grams and we add that up to this. So let's go ahead and just say that we're working with 16 grams here, okay? So I'll go ahead and write that in. So we're working with about 16 grams. Well, when we add up our 16 grams with our 2 grams, that gives us 18 grams per mole. Okay, so there is our molar mass of water. Okay, so we need to go ahead and convert 25 grams of water into moles of water. Okay, so let's go ahead and take a look back at this scheme over here. Back here, and wrap this problem up. So we have 25 grams of water. I'm going to put that over 1. Okay, and then remember, we divide by the molar mass. Okay, so we have in 1 mole of water, we have a mass of 18 grams. Okay, so that gives us, just get my 25 grams times 1 mole over 1 times 18 grams. Remember that we multiply across first, okay? Multiply across. Okay, so 25 grams times 1 mole. Okay, we have grams and grams here. And I am going way over the 10-minute estimate I said at the beginning of this video. 25 grams and 18 grams. So the units of grams cancel, leaving us with just moles, okay? And then we plug that into a calculator, 25 divided by 18. 25 moles divided by 18. And that gives us 1.4 moles of water. Okay, so there you have it for the first problem. Okay, oops. So let's go ahead and go. Okay, so here's our second example. Still converting grams to moles, moles to grams. In this example, though, okay, notice, okay, now we're going from moles to grams. Sorry, I know I paused there for a second. We're going from moles to grams. In the last problem, we went grams to moles. Now it's the reverse, okay? So if we go ahead and, okay, first thing we do, as always, is we determine the molar mass of CO, right? That's the compound that we're working with. So we have carbon and we have oxygen, okay? So if you were to look at your periodic table, you would see that the molar mass of carbon, the atomic mass of carbon is 12.011 grams, right? And we don't have to multiply that by anything because we only have one carbon. Now we look at oxygen and it's the same, right? 15.999 grams. And again, we only have one oxygen, okay? So let's go ahead and do the same thing with oxygen. We're just going to go ahead and round this guy up to 16 grams. And we're going to add 12 grams to our 16 grams. And that gives us a total molar mass of about 28 grams per mole. So that right there is going to be the molar mass of our CO, okay? Now, here comes the math, right? And we just referenced our little multiply by the molar mass then, all right? We have 1.5 moles of CO. We're going to put that over 1. Okay, and we're going to multiply by the molar mass, right? So in 1 mole of CO, we have a molar mass of 28 grams, okay? Same thing, we multiply across, right? And that gives us 1.5 moles times 28 grams over 1 times 1 mole. Well, again, remember, we want to get rid of moles. So in this case, moles is going to cancel out, right? Leaving us just with grams, okay? And we end up with 1.5 times 28 grams. And that gives us about 42 grams of CO. Okay, so there's your answer for the second problem. It's a periodic table, okay? So we reference our periodic table has a mass of, there it is right there, 12.0107. Let's go ahead and look at oxygen. Oxygen is 2 elements over, and it has a molar mass of 15.999, okay? So with hydrogen, and we are also working with oxygen, okay? So here's our oxygen, and here's our hydrogen, okay? So we have H2O, right? So we have 2 hydrogens and 1 oxygen. Atomic mass of hydrogen, okay? Hydrogen's right here. So it has an atomic mass of 1.00. Oxygen is right here. So it has an atomic mass of 15.999 grams, okay? So let's go. Okay, now moving on. We're no longer working with grams. Now the focus is going from moles to molecules and molecules to moles, okay? So this first problem says, determine the number of NH3, it's ammonia, molecules in 5 moles of NH3. Okay, so we want to know the number of molecules we have in 5 moles. Okay, so in this case, we are going from moles to molecules. Okay, to this problem here. So we're going to multiply this by Avogadro's number, right? We don't need to determine the molar mass in this problem because, again, we're not working with grams. Okay, so we have 5 moles of NH3. We're going to pop that guy over 1, right? And then over here, again, we're multiplying by Avogadro's number. So we have 1 mole of NH3, and in 1 mole of anything, you have 6.022 times 10 to the 23rd. So that's exactly what we're going to write, 6.022 times 10 to the 23rd NH3 molecules. Okay, remember, same thing. We multiply across first. And again, if you guys just want to get ahead of this, that's all good to me. We have 5 moles times 6.022 times 10 to the 23rd molecules over 1 times 1 mole. Okay, so moles cancels, right? Leaving us just with molecules. Okay, and we end up with 5 times 6.022 times 10 to the 23rd molecules. And you should end up with an answer of 3.0 times 10 to the 24th molecules. Now, after solving that problem, and I'm sorry, that's molecules of NH3. I realize that some of you may not have graphic calculators and some of you may not be aware of how to solve for a problem like this using your phones. So what I think I'll do is go ahead and look for a website online, and I will, there's a couple of good websites out there that I can think of. I'll go ahead and post another video of how to go about that so you can solve these types of problems, because I understand that using scientific notation can be tricky if you're not really familiar how to do that. Okay, so that's our problem. That's our answer for this first example problem. Okay, we have one more problem, guys, and I apologize for going over the estimated 10-minute time period. This is my first time using this platform, so I kind of blame it on that a little bit, and then I also kind of realized that realistically, 10 minutes just might not be enough. But we'll see. We'll see how things go moving forward. Okay, so let's go ahead and move on to our next problem. Okay, so we have moles of NaCl, and we want to know how many NaCl formula units we have. Okay, so how many moles of NaCl are in 7.9 times 10 to the 24th NaCl formula units? Now, I didn't write molecules here. I wrote formula units because this is an ionic compound. Okay, so with ionic compounds, we refer to them as formula units. Okay, so don't let that throw you off. Okay, if you want to pretend that says NaCl compounds, that's fine. Okay, now we're going again from molecules to moles. Okay, so that then we're going to divide by Avogadro's number. We have 7.9 times 10 to the 24th NaCl. Okay, and I'll just leave it at that, NaCl, right? I'm going to put that over 1. Okay, and then over here we have 1 mole of NaCl, and underneath that we write Avogadro's number, because in 1 mole of anything we have 6.022 times 10 to the 23rd, right, NaCl. Okay, so same thing. First thing we do is multiply across, and you'll see that what you end up with is 7.9 times 10 to the 24th NaCl. Oops, getting ahead of myself here. Divided by 6.022 times 10 to the 23rd. And this should be moles. Okay. Now, what this gives you, once you plug that into a calculator, you should come out to about 13 moles of NaCl. Okay, so